Okay. Hello, everybody. Welcome to the Nodes 2020 extended session today on 17th of November. Welcome, everybody. Thank you very much, Nathan, for joining me today for this live stream today on this extra session, basically. We have a little time delay because my machine was messing up, so sorry for that. We are, I say, a little bit delayed, but I hope you're still happy with that. Nathan, are you looking forward to today's session as much as I am?
I am very much looking forward to this session. I think it's a really interesting topic that we have coming up, and I just appreciate from the community perspective how many people have been willing to put in the time and effort to prepare for these sessions. I really learned a lot from the ones already that have happened so far.
Yeah, and today should be no exception. I think I'm very happy to have. We are very happy to have Mayank here joining us today, talking about metrics-driven Agile and DevOps transformations using Neo4j. I think that's going to be a very interesting topic, and that's going to be very insightful for everybody. I think lots of people have expressed their interest in this specific topic. Metrics-driven always is like a buzzword, basically. So everybody's jumping on it and say, "Oh, I want to know more about what's going on behind the scenes, what the metrics are, what's going on. I need more insights." Is like a very strong keyword, I think. And then, Nathan.
Yeah, absolutely. As we think about graphs are everywhere, and how as developers we can drive adoption of this technology within our organizations, this is one use case where we kind of have a little bit more control sometimes and influence in terms of how graph can be adopted. And so I think it's a great opportunity for us to learn from Mayank today.
Yeah, me too. Let's maybe add him to this session here. Switching over now. Welcome, Mayank. Thank you very much for joining us today. I just grabbed your LinkedIn IO you wrote about yourself, and I'll read that now. I hope that's fine. You say
Sure.
you say you are an experienced consultant with a demonstrated history of working in the information technology and services industry. You are skilled at Python, DevOps, consulting, pre-sales, and implementation, so all around DevOps master. I have to add here. AWS, Chef, Data Analytics, and Maven are also some of your skills, and you are a strong consulting professional with an engineer's degree focused in information technology. So we are very happy to have you on this stream today.
Thank you, Alex.
And do you want to give a little roundup what's going to happen today, or shall we just dive into the presentation and do talk later?
So today we are actually going to cover how we can actually derive Agile and DevOps transformation, like Nathan said, right? Using the power of correlations and Neo4j. So what we are basically going to see is that what are the basic transformation challenges we do see, and how do we actually overcome these challenges using the graph models. So that's the basic construct of today's discussion.
Cool. All right. Anything you wanted to add, Nathan, or shall we dive in?
I'm ready to go.
All right, let's dive in then.
Sure. All right, so I hope my slideshow is visible and looks good. Perfect. I'll get started now. So hello, everyone. Thanks for joining this session. I'm Mayank. I'm actually working as a DevOps architect with Cognizant for about 6 years now. I love to work with different tools and technology and actually implement them for our customers. I've also co-invented a unique approach in DevOps measurement area. Just for further references, I've just given the patent number and the patent link on the slide as well. Apart from work, these days I am actually trying my hands in cooking. That's kind of a COVID-forced hobby for me. I have to cook sometimes. And then I'm delivering this presentation right now from Toronto. Okay, so let's get started. To set the context here, right? So we are talking about metrics-driven Agile and DevOps, right? Both of these terms are very common in today's IT world. Basically, they are part of the same coin. where Agile will help you develop the software faster, and DevOps is going to deliver that software faster to the end users, right? And what you're seeing on the screen is different phases, which actually constitutes a basic construct of DevOps approach. What it essentially means is that we do a certain set of activities aligned in an engineering pipeline shape and form. We'll talk about the engineering pipeline, what we mean by that. And then in each of this phase, like continuous planning or integration or delivery, right, there are n number of tools that we use in today's IT world, right? So for continuous planning, tools like Jira or Rally, we use it. For continuous integration, we use something called as Jenkins, right? For deployments and feedback, we use tools like Rundeck, Qdeploy, and testing tools also comes into the picture. So there is a bunch of tools, and then there is a bunch of processes that comes together to make this DevOps thing work, right? Moving forward, I also wanted to quickly talk about in our next two slides about the challenges that we see for Agile and DevOps transformation for large-scale IT these days, right? And this actually becomes our use case for our today's discussions. And how do we use the power of GraphDB or Neo4j to actually overcome these challenges that we see across the industry? So to begin with, the first one is multimodal ID. Large portfolios, right, are not 100% digital. They kind of deliver cohesive apps, right? Example, it could be a mix of legacy applications, or it could be COTS product like SAP or Siebel, or it could be Java, .NET application, or there could be some microservices that is coming up these days, right? And each technology stack can actually have a different DevOps construct, right? So how do they deliver DevOps, right? So that becomes a little challenge. How do we actually have a unified way to measure Agile and DevOps in this scenario? Another one is varied maturity. So this is more from a cultural aspect that people with varied skill sets are actually following Agile and DevOps and at varied maturity levels, right? So how do we actually bring them together? They are par excellence in silos, but how do we bring them together? Another one is lack of centralized governance. So in many of our customer base, what we are seeing is that KPIs and metrics are actually viewed in isolation, right? So how do we bring them to a single pane view? So to bring it to a single pane view, we need something to become a single source of truth for us, right? So that is where we are going to head towards using Neo4j. Another one is lack of traceability, right? There is discrete data present in n number of tools that we use. How do we actually organize this data in a form where we can utilize that data and take some informed decisions on it, right? With that, the next one, which is also a big one, I talked about the two slides, right? So this tools ecosystem, there is a problem of plenty already there in today's IT world, right? Every customer nowadays has actually embarked already on the DevOps journey. Some are really ahead, some are just starting, some are in their mid-level somewhere, right? And in this journey, everyone is actually using a plethora of tools, right? So then we have a problem of plenty, right? Some of these tools do talk to each other, some does not. And even though if those tools talk to each other, the data beneath those tools are still residing as two separate sources, right? So how do we actually create a data source which can act as a single source of truth with end-to-end traceability, right? So we talked about so many things that we need to solve to address these, right? And answer to all this is a GraphDB, which we are using a Neo4j. So moving on, we're talking about pipeline, right? A couple of times I mentioned about pipeline. So let's talk about what a pipeline is and how it looks like in general, right? So DevOps toolchain integration, we integrate different set of tools for doing different set of activities in SDLC. So for example, in our planning phase, we use Jira. And then once the planning is done, we go ahead and write some code over it, right? We use the common tools are GitHub, Bitbucket, right? And then we build the tools like something like Jenkins, right? And then we deploy tools using different tools, Rundeck, Qdeploy, etc. And then we move on with different phases. So when these phases are actually connected together with some toolchain integration, we call it as an engineering pipeline. So we gave it a thought that, okay, this pipeline is there in so many places. How about reconstructing this pipeline as a graph model, right? So how do we actually reconstruct this? What we do is we collect data in a push or a pull mechanism from these different Agile and DevOps tools. We create nodes in Neo4j, right? And then in the background, we run a correlation engine, which actually identifies that how these nodes can be related and generates those relations and form a graph for us. And how do we make those relations? Just to give a sneak peek into it, a Jira user story can have a commits association within it, right? And when it progresses, a build can have the information that, okay, which pull request it is building or what is the head commit that it is building. When we go into the deployment, that we know that, okay, this particular artifact is we are going to deploy into into a particular environment, right? And then we are going to do some testing on it and then release it. So there is always information is actually getting moved from one phase to another. So we have the backtracking of it. So using that information, we create relationships in the background, right? And then we use the power of Cypher query to visualize these KPIs. Now, visualization of these KPIs, we are using another open source tool, Grafana. This is also a very powerful tool, but Grafana is not providing any connectivity to any graph database as of today, because they are merely based on the time series databases. So we have written a custom plugin so that our instance of Grafana can actually talk to Neo4j and execute Cypher queries and generate graphs over it. Right. So we will see all this in live in action in Neo4j in about a couple of minutes, right? So before that, I just wanted to cover a quick caselet here, right? So using this approach or this framework, we actually achieve the data-driven results by creating this single source of truth, right? We could actually measure and improve the effectiveness of Agile and DevOps for a leading enterprise here by taking some informed decisions. And how could we take informed decisions? Because we have the data-driven answers for the questions which are actually getting popped out here, right? Can you really identify the bottlenecks? What is the weakest link in my release cycle? Can you actually measure my release readiness? Is my artifact ready? How many definition of done items are checked for that artifact, right? Can you trace my artifacts back and forth? Like, for example, if somebody asks me that in a production server, there is a particular software artifact deployed ABCD with version XYZ. Can you tell me which release actually built that? Right. So the question to this answer is not really straightforward. It takes some time and effort to identify and backtrack that. But if we have the engineering pipeline reconstructed as graph, these questions are just a click of a button. So I'll show you that in the demo as well. And last but not the least, we can also continuously improve on DevOps adoption. And how we can improve on DevOps adoption by only means is that we measure where we are today, and then only we'll be able to improve on it. So there are ways to actually measure the DevOps adoption with some formulas using Cypher queries itself. So I'll show that in our demo as well. Moving on, right? So we talked about so many things so far, and the secret sauce is actually correlations behind the scenes. So we collect data and we relate them in an organized form, and that actually gives us the key to slice and dice the data back and forth as per our metrics need, right? So actually it's time for a demo now. So I'll show you some live action here. So when we move on to demo, you can expect three major use cases that we are going to cover. So we are looking at graph model, right? We are talking about the engineering pipeline. We will visualize the pipeline with multiple levels of relations for different tools by executing some Cypher query in Neo4j browser, right? The another use case will be slicing and dicing the data. So once we have the humongous data of that engineering pipeline with us, that how can we actually slice and dice the data by writing some very, very simple Cypher queries, and which give us like good results. And that information is really meaningful, and it takes a lot of time and effort if we don't have this engineering pipeline constructed with the help of Neo4j, right? Another use case which I'll show you within the demo is visualization. So when your graph becomes a little heavy with maybe 150 nodes, 200 nodes within it, that becomes a little difficult to consume directly, right? So we have created a easy to consume format, a custom screen within our framework to visualize this engineering pipeline. We'll also come up with some visualization of these license rights of data points that we can do. We can also check some productivity measures at different levels, like at different hierarchical levels, portfolio level or a product level or a team level, right? There are different levels we can measure that. And then we'll also cover a quick screen on DevOps maturity. How do we actually measure that? So let's jump on to the demo now. Let me log on to the server here. Okay, so I have some favorites queries saved in here. So let me start with my first query here. So in this query, what I'm basically trying to do is I'm just fetching a release, and then I'm just going no level deep, just one level itself, the same release level I'm sticking to. This is just a relations syntax. And then given a release name, since this is my demo box, I just named it as release 1. So I just need to know that, okay, for version name release 1, what do I have in my system? So I do have a release node here, which says that, okay, this is the project associated to this release, this is the start date, end date, or if it is released or not, some of the information is there in this node as properties. Now, just rethink about the engineering pipeline that we talked about a few minutes back, right? So that the next logical progression of this planning is that, okay, I do have release, then I will have some stories, bugs associated to them, right? On which people will actually come and developers will actually come in and work on it, right? So let's see, as the logical progression, I'm just going another level deep with the relations here now. So if I see this, I will see that, okay, there are story, bugs, and tasks associated to this release, right? So the team will come in, and how do they accomplish these tasks? They will write some piece of code, and then that piece of code will actually go into some version control system, right? So that's the next logical progression in the engineering pipeline. So let me go to the level 2 now. So if I go to the level 2, the graph expands from release to a story to these number of commits associated to this story, right? So once the commit is done, the next logical progression, we need to build that artifact, right? So how do we actually build that artifact? We'll do some builds using tools like Jenkins or any other CI tools for that matter, right? So let's see, by increasing another level here, right? So I'm going one more level deep in my relations now. So now I see that, okay, there are builds happening with Jenkins on these commits associated, right? So what happens after the build is done? So if a build is done, an artifact is produced. It will be probably uploaded to a binary management tool, something like JFrog Artifactory or Nexus Pro, right? And then we will have some sort of testing once they are deployed to a certain set of environments, right? So if I go another level deep, level 4 here, let's see what happens to the graph. Now this graph becomes a little overwhelming with so many nodes moving around. But the very good part about this is now we have the information at our hand, and we can do back and forth with this information and create n number of metrics. The possibilities are kind of endless. Whatever is our need with this data, we can just write some Cypher queries and get the data out with end-to-end traceability. So that's how I wanted to show this. How are we constructing and expanding this engineering pipeline as graph model? Like you see here, after build, it's getting deployed to int or a dev environment, and then we are doing some regression or smoke testing on it, right? So the next section of the demo use cases, right? So we have data. How do we slice and dice it? Now let's pick up some quick examples for demo purpose. Let me go back to my favorite queries. I have a couple of them here. So in the first one, what I'm trying to do is just given an artifact name, can somebody tell me that what is the release it is associated with, right? So this information, it's not like that it's not available. But to get to this information, trust me, it really takes good amount of time and effort in large-scale IT to identify that with thousands and thousands of artifacts being produced, right? So it's just a click of a button because we have this engineering pipeline. Let's pick up another quick use case with a simple Cypher query. Given a release and given an environment, can I get that, okay, what all are the artifacts with their versions which are actually deployed in this environment which are actually built for this particular release. So again, that information is very quickly available just by writing some simple Cypher queries here. Another use case which is a little complicated and with some medium complexity actually. So I would like to show that, and the reason why I'm showing this a little bigger Cypher query here, just to emphasize on that Cypher is again a very powerful tool which can help slice and dice the data in various forms and shapes, right? So what I'm trying to do in this particular use case is that given a release, somebody will just come in and say that, okay, hey Mayank, this is the release. Now tell me the latest and the greatest artifacts deployed with version and date and time on my environments. I need to know what's deployed for this release in dev environment, what's deployed for this release in integration environment or pre-prod environment, right? So that's the quick use case I'm planning to show here. So beginning with this, I'm just keying in release here, getting the release out of this. Using this release, I'm just getting the associated Jira here. Again, just think about the engineering pipeline in the background. And then once I have the Jira data, like story bugs associated to it, I can get the commits associated to it. Once I have the commits associated to it, I can actually go into the artifactory and get the artifacts which are produced, which were like produced for those commits, right? So then I get this information, I collect this information in collection so that I can get the latest and greatest nodes out of it, right? And I'm just defining some environment arrays here in large scale IT. There could be multiple environments. We can just mention multiple environments here. And then I'm using some cool Cypher functions like filter, any, head. So the reason to show is that we have a good amount of stuff available with Cypher to play around with the data, right? And then at the end, I'm just transposing the data in for a better visibility in a table format, right? So let's see what the Cypher query returns. So if I run this, it will give me that, okay, for release 2, in dev environment, I have artifact 2 with version 102 and which was deployed on 5th of Jan, right? In integration, same version is deployed. It was deployed 2 days later, 7th of Jan. While in pre-prod, I'm having the same version, but an older, same artifact, but with the older version here, and which was actually deployed before even this version was created, 102 was created. So again, just click of a button, we get a good amount of information, right? So I will move on to the visualization section of my demo use cases now. So let me log into the framework that we have built, and we have actually open sourced it as well. So I'll share those details as well. So all this code is available in GitHub as open source for a community to leverage that. So let me go back to my traceability dashboard here, which is actually a very good tool to visualize the pipeline, right? So to you remember, just to refresh that, when we see this data, right, this data is right here with so many nodes popping out, moving around, right? So let's see how we can better visualize it in horizontal and vertical movements of SDLC. Let me select Jira. The data sets are different because it is demo server, so you might see some different data points here. But the intent is to show the concept out here. So if you see this one Jira story, actually, how is it moving vertically and horizontally in the SDLC? So if we see horizontally, these Jira stories getting converted to some commits. Those commits goes to build, some static analysis. Rundeck is using Rundeck, we are doing some deployments, right? That's the horizontal movement. And then we have the vertical movement as well. So like within Git, how many commits are there? Within CI, how many builds we have done? What are the status of this build? How much time it took? Same thing for static code analysis with Sonar, right? And then actually just with the click of a button, you can visualize that, okay, this is the time the commit was done. This was a Jira key associated with it. Who was the author of it? Who did that commit, what is the commit ID, right? So all those details are available right here. Similarly, you can go for the CI status. You get the details all in just at one place. And all this is possible because we have that engineering pipeline as graph. So that is one view. Let me move on to a couple of more views, and then we will jump back to our presentation and see what's left in there. Right. So we talked about the slice and dice of data, right? Once we have this pipeline. So I'm just showing a couple of quick examples for slice and dice. So now this is Grafana, which we are utilizing here. But like I said, it does not talk directly to Neo4j. So we have just added a custom plugin as a data source within Grafana to actually connect to Neo4j. Then what I'm trying to do, this is sprint scorecard, which is getting data from different tools like your Jira, your version control system, your CI engine, your deployments, right? And then collating into a single pane view, right? And then how all this is possible? This is just possible with some minimal engineering effort. And what is that effort? It's just writing some quick Cypher queries, right? Once you write these Cypher queries, the Cypher query gives you a response back in this JSON format, and we are consuming this JSON format and actually creating these charts using the Google Charts, which we have also embedded within Grafana. So that's how easy to actually create these n number of visualizations with writing some Cypher query. So possibilities are actually only limited to what Cypher queries we can write with the data set that we have. So there is a humongous possibility for generating n number of matrices. So coming back, we talked about a little productivity and hierarchical stuff as well. So I'll show you that how we can arrange that quickly here. So like, for example, with that set of data that we have, we can actually measure productivity, predictability, and actually current delivery status, what's going on right now. So, and that could be done at portfolio, product, team, or sprint level at different levels, right? So what I mean to say is that, okay, the number here is BTG 2.733. So that means that BTG as a portfolio, which can have like n number of Scrum teams within it, is actually delivering 2.7 worth of story points on a daily basis on an average, right? So when it comes to predictability, we say that, okay, we have some past data with us. So we just calculate that, okay, in the past 3 sprints or five sprints, whatever they are actually committing and how much they are actually completing, that ratio is coming around 87%. So we are just saying that we are predicting that in the next release or in the next sprints as well, they will probably completing the 87% of the work they are going to commit. And what's the current status of it? So right now about 1300 odd story points they have committed in the current sprints, which is going under the portfolio BTG. Again, there could be multiple Scrum teams, right? And out of which about 1100 story points are already completed and the work is actually going on. Now the same thing can be visualized at product level individually. The same thing can go into more granular level, like at sprint level. The same thing can go on some time range, time scale as well, right? So like in December, we have the productivity as 2.3 story points getting delivered on a daily basis. Maybe many people were on leave. In January, people came back to work probably, and then we have some 2.6. The productivity is actually kind of little increase. So we can just measure it in different ways. So I'll move on quickly to another piece of information that we can utilize from that engineering pipeline that we have in the database. That we can create these number or come out with these numbers to measure a DevOps maturity progress, right? So DevOps maturity progress will be combination of different vectors. Those vectors could be your build vector, your verify vector, or your deploy vector, right? Now each of this vector will have some formula within it. Now this formula is actually very customer specific. In every customer's ecosystem, that formula could be different. So people can say that, okay, I don't want to utilize this particular aspect while calculating my build maturity, or I really want this additional parameter going into it. Now, how do we customize these kind of formulas at every customer location? Now, that's where Cypher helps us. So if I just go ahead and edit this, how this data is getting generated, again, this is just some Cypher query which has that, okay, calculating the percentage of orphan commits that we have, calculating the sonar statistics those commits are producing, or calculating the broken builds from the Jenkins data, right? So there could be a number of parameters that can derive me this number, and that number of formula is actually keyed into Cypher. So we can change it at our will. So I'll come back to the digital transformation. This is just another view. I'll not spend too much time. So this is just saying that how much time your features are actually residing in which type of environment. What is the time in dev, holding time in dev? What is the timing, holding time in Q? And what is the probably time elapsed it went into production? So that is also really available and handy to us, again, just because we have the data structured in the graphical model. So with that being said, I will move back to my presentation and let's see what we have there to cover more, right? So let me come back to my presentation. So with that being said, I hope that we have what we have seen so far might have generated some interest. And probably we believe there is so much more to achieve with the power of graph, and there are so many new possibilities that can be leveraged. So for example, this first use case right now on the screen, leveraging the data collected to predict new relations and identify outliers for our Agile DevOps use cases, right? So just for an instance, just assume that there are two nodes, node A and node Z, right? So what is the path the graph is taking, right? That will give you actually a score or a number of links or hops it is taking to reach from node A to node Z, right? And if these links or these hops are more than a threshold value, for example, too many subtasks associated to a Jira story, or n number of times a particular defect is actually reopened and closed, right? So when a defect is created, we'll have a base node. Then every time it is getting reopened and closed, we will have that additional loads link going out of that base nodes. So that really becomes easy for us to identify those outliers, right? Second point, like recommendations and suggestions for course correction, right? Expanding our engineering pipeline with app monitoring tools, right? Once we collect the data from those app monitoring tools like Nagios or Dynatrace as well in near future. So we can actually collect each notification which is coming onto our servers, logged onto our servers, and then we create a node out of it as a first step, right? And then each of those nodes is actually linked to a base problem. And step number two, probably when an action is taken, there will be probably an ITSM ticket involved, something like ServiceNow in large scale ITs, right? Where people take some action on a production server that is documented in a ticket form, right? So that particular action which is being taken, that will create another node which will be linked to the notification that I got, right? As a step three, once a reasonable size of nodes and relations are there in this fashion for me, then probably we can have a recommendation engine which will auto suggest some action based on my past relationship or past actions that were taken, right? There are a couple of more use cases which we believe can be explored, something like graph computations to measure impact of software release. The patent I was talking about in the beginning that we got way back in 2018 is talking about the cost of a release. Right now we are talking about impact of a release, right? So that impact could be technical, business, or actually revenue generation. I'll just give a sneak peek into it. The thought behind this to actually create some milestone with combination of few systems, like some details from pipeline that we are trying to create as graphs, some details from the app monitoring tools, and some details from the business KPIs. Combination of all three we believe can give us the impact of a feature that is getting released into production or which is getting delivered to end user, right? Another one is productivity and hotspot measurement. So productivity and hotspot measurement can also be calculated with the help of graph here. Like for example, enterprise tools for time management like Clarity or Primavera or Timesheets, right? So people use them, but that data is sitting in silo. And the SDLC data, which is actually we are doing the work, is sitting in silo. How about relating or connecting these two data? So for example, if I connect the time logged in Clarity to the work done in the SDLC using the engineering pipeline, I will probably have how much time I am spending on which particular feature. And then if needed, can be extended with a dollar value as well, right? So another one could be hotspot measurement. Now, hotspot measurement, our thought process behind this is to collect high friction code files. So for example, or for instance, if a change is made to a particular file or a set of files, right? And then we see instantly there are many instances of broken builds or defects getting open, right? And we have a good amount of past data to conclude that. Then as soon as we see a change in those high friction files or a set of files, we can send out a few alerts that, hey, it's a caution. In the past, whenever we have changed this file, we have seen some issues going around, and these were the past issues associated to these files. So just a kind of a caution to be proactive on what is going into our production environments. So, and all these and there are some Neo4j data science algorithm. We are just scratching the surface as of now, not went too deep into it, but there are algorithms like we found interesting, which could help us explore some of these use cases, and which I think will be useful in this case will be similarity, pathfinding, and then link prediction algorithms that we have. So this is just to give you an idea that there is humongous new possibilities with power of graph. So with that being said, I am almost done. We'll go for questions. Just before that, I will just share a couple of links with you guys. This is our GitHub link right here, which has the open source code of the framework that I showed you. And this is the documentation link. We are making a religious effort to keep it well documented and keep always up to date, so that people can follow this and leverage this framework. And then this is just my direct LinkedIn link, and you can reach me out for any further details. So with that, I'll pass it on to Nathan and Alex for any questions that we see.
Super, very, very cool. Thank you very much, Mayank. This was very, very impressive. How cool was that dashboard, Nathan?
It was beautiful. Yeah, as a data scientist, my eyes are lighting up.
It's super nice. Yeah. If you have any questions, dear chat, post them in the chat. I've seen a couple, but I have one maybe first because I get first dibs on that. Is you mentioned the problem of plenty and all this, or how difficult it is with all these various data sources, how to get everything together. How different, maybe just to shine a light on it, how difficult was this, like you said, show who was the author, who on which environment, and which version was the recent release? How difficult was that before you decided to do this with the graph implementation?
Okay, so before and after with this graph engineering pipeline, right? So before, I will say that information was all there. It's nothing like that the information was not there. It was there. People are working on it. Tools are there already. But when we ask simple questions, right, which I showed in the slice and dice format, right? Okay, given an artifact or given a release, can you give me the artifacts? So then people actually hover around, struggles a little bit to find that information in n number of different tools and try to relate that, okay, this is my deployment tool. Actually, this deployed this, but I don't know which release this deployment is done. This is just the deployment, and this is done and so time. I don't know where it is, which code went into that, or which release actually it traces back to. So that information was, I'm not saying it was not there, but it really was a real pain to find that information, because we have to talk to n number of people to get that information, search in n number of different tools, and then get that answer. But with this engineering pipeline, it's just automated, and with the click of a button, the information is right there for us. We don't have to go and reach out to different peoples to get some answers.
Beautiful. I think that is that is much easier for everybody involved. I have one question from the audience. MH Yell asked, "How is data getting into your graph?"
Okay.
Yeah, maybe you go into that a little bit.
Sure. So there is two ways the data gets into our graph. That is either a pull mechanism or a push mechanism. So when we say pull mechanism, we have lightweight Python agents written, which makes REST API calls to this agent, to these different DevOps tools, and collect data via REST API and then organize them in the graph. Another one is like push mechanism, where we utilize webhooks, like something from the GitHub side. We set up some webhooks, and then whenever an event occurs, a JSON file is actually sent to MQ channel, and from that MQ channel, we consume that JSON and create nodes in our graph database. So that is just the high level of it. So if you actually go, if you want to go deep into it, go onto this link, and there is a complete agent framework is available there. You will able to visualize in more details how exactly that agent framework is working.
Cool.
I hope that answers somewhat, because it's just a little deep dive topic into it. But in a nutshell, REST APIs and webhooks.
Yeah, that makes sense. So as you've worked with different customers, I'm sure they each have a different stack of tools that they use to do this kind of development. And you're able to integrate using those same tools across various different tool sets at your customers.
Yes, they are. There are like a plethora of tools used for every single activity within SDLC. So, for example, I've seen people using multiple CI tools. I've seen people using in the same organization multiple instances of Jira, or they are also using Jira and Rally combination. Some area uses Jira, some area uses Rally. So that problem is very evident there in across our customer base. Did I get your question right? Was there a next part to it?
No, thank you. That makes sense.
Okay.
We have one more came just in from Elazal. Have you seen any correlation between the number of stories, incidents, and the issues further down? I guess the deeper you go into the rabbit hole of the graph.
Right. So we have seen that association because we also have an agent for ServiceNow, right? So that ServiceNow has a CI item into it, right? What is the configuration item onto that? Then if that item, if they're using it wisely, the setup is done wisely. That actually relates back to my artifact name, could relate back to that CI artifact. Then if I know that, I can actually relate my SDLC data to my ITSM data. And then if I do that, I can say that for this particular artifact, there are more number of incidents or production incidents getting generated. And if I know this artifact with this version, then I can relate it back to, okay, which release, what was it released for, when was it done? So all that data can be related. But yes, it is all data in and data out. So how we are actually using the tools, how well our tools are actually configured, that actually is also very important. So when we actually engage with this kind of a framework, we also come up with some recommendations. How do you actually configure these tools as well?
Yeah, I can imagine, especially when you go there, and then you have once you have the answers ready for you, it just makes your decision process also much more. There's a foundation for what you decide what to do next.
Right. Because I mean, it's like whatever data gets in, that's how we can generate the metrics for. And if the data is not right, then nothing would actually work. The data needs to be right.
Absolutely. Yeah. One more question, maybe for large enterprise from HD Wolf. For large enterprise, what will be the starting point if they plan on implementing this graph model, or this similar tool like you just showcased? Will it be central governance or any other use cases around it? Is this so basically maybe how would you go as a large enterprise and start with the process? What would be your first steps?
So when we engage with a large enterprise, the first step is to work with a centralized governance team. Usually there are centralized governance teams or set COEs there, which are either responsible for DevOps or the tools ecosystem, right? So we start our conversations there. We try and understand their tools ecosystem, what they use, and what are their current processes. And then we do some homework, coming back to the drawing board, that okay, what do we already have to match up their ecosystem, and what we don't have, and whatever we don't have, how we can actually patch it up to make the things work end to end to them. And then we come back with that whole story back to the customer, and then explain that okay, this is n number of items which is already there, plug and play, work like a magic. And there are a couple of items that probably you need to work we need to work collaboratively to get the desired results, and this will be the time frame that we are looking at it. And then we usually start with a POC, just by onboarding a couple of applications to begin with. And then we move forward slowly. We just start small with one or two applications, and then we build on it once we start delivering the matrices for those applications. And once people see that okay, there is value delivered with these matrices, then the adoption is an outcome. Actually, adoption increases.
Yeah, this is like similar to what we usually see at generally at Neo4j. Is usually we start at a smaller project, a smaller scope. We go for it. People implement it. People see the benefit, see the value, and understand. Oh, this is actually really useful now. And then it grows, and then a new department want in as well, or some new use cases is being switched on as well. But start small, get your scope right, and then try what you want to do with it, and then see the results, share the results. Maybe visualization is an important part of it, like you showed in the dashboard. And then once people realize, oh, actually, wow, this is so easy now. This is what we wanted all the time. We don't have to ask 15 people around to get this answer now. We just need to refresh that page.
Yep.
And then the other departments come around and say, hey, can you also do this for me, and can we be part of it? And then it grows. Yeah.
Yep.
Cool. Do we have more questions, Nathan? Do you see any more questions?
Yeah, it looks like another question came in about, it says you talked a bit about using this with further data for identifying prioritization. How might you see this working?
I missed that word in the further data for prioritization.
Right.
Okay. Probably, can I ask, I'm not getting the question completely. Data for prioritization, if we can elaborate that a little bit.
I suspect that they're talking about prioritizing development work, knowing which items in the backlog are most urgent or most important.
Okay. So yes, there is a k-means clustering algorithm. Again, we are just scratching the surface there as well. So there is a k-means algorithm by which what we are trying to do is that we're trying to feed in the user stories, past user stories, and what are the story points, and the prioritization assigned to those stories, right? And with that, some of the verbiages, the story points are assigned, or the priority is assigned, right? So based on that past data that we have, we are trying to come up that okay, if your story is written in this particular fashion, if it contains these many keywords, or this many subtasks within associated to it, so that is the recommended story point for it, and probably the recommended priority for it as well. So it's in a very nascent stages. We're not even sure that when we will when we will be able to accomplish that, but that is somewhere we are taking a path towards that, while helping out people in the PI planning sessions, that okay, if this is my user story, 5 people come in and they say that okay, based on our experience, put this story points, these many story points, or let's put this priority on this particular user story. How about getting a recommendation on the past data that what we are already delivered for prioritization and story points?
Oh, that's really interesting. Do you have other use cases where the graph data science library has made a difference with this data, maybe for weakly connected components to identify different sections of the code base, or different communities within the code base that are more tightly connected to each other?
No, like I said, we are just embarking our journey for the data science algorithms. We have not seen any outcomes out of it yet. So we are still in the nascent stages to try that out.
Makes sense.
That's great.
That's cool. I think we covered all the questions. I don't have any more questions. Nathan, do you have anything else?
I don't, but thank you so much, Mayank. This has been really a great session.
Yeah.
Thank you so much.
This was very good, very insightful. I mean, I said in the beginning, this dashboard was just amazing. It's super cool. I think everybody likes it. Who is who is using it? I would clearly be liking it. So yeah, I think that's great. Thank you very much for taking the time. Thank you very much, Nathan, for co-hosting with me today. Yeah, I think what I can say is we are doing this next week again. Until then, stick around and have a good rest of the day. Thank you all.
Perfect. Thank you.